Welcome to this video on steam locomotives in the Harz region, tracing their journey from serving as mining pumps to becoming a tourist attraction. We will explore the history, technology, and heritage of these magnificent machines. Our video focuses on the steam locomotives in the Harz, highlighting their evolution. See the transformation from a mine pump's power source to a beloved tourist symbol. A steam locomotive is a traction vehicle powered by water steam, typically generated in a coal-heated boiler. The steam energy is converted into mechanical movement for the driving wheels. Key components include the steam boiler, firebox, steam cylinders, crank mechanism, and driving wheels. This technology was the first mass-applied means of mechanical transport on land. Mining faced a major problem in the 17th and 18th centuries, mines flooded by groundwaters. The resolution was the steam pump. Thomas Newcomen invented the first practical steam engine in 1712, where steam powered the piston that drove the pump. Mining and coal were crucial to the age of steam. James Watt, a key figure in steam engine development, introduced the centrifugal governor. This mechanical device automatically controlled the machine's speed, reacting to changes in RPM without human intervention. This improvement made the use of steam safe and stable. George Stephenson, a steam railway pioneer, created the rocket in 1829. It was designed for the Rainhill Trials competition for the Liverpool-Manchester Railway. The goal was to find the best locomotive for regular service. The rocket introduced several technical innovations that became standard. These included the multi-tubular boiler for greater heating surface, the steam blast pipe for better draft and combustion, and direct drive of the driving wheels to lower energy losses. The rocket achieved a maximum speed of approximately 45 to 50 kilometers per hour, had a mass of about 4.3 tons, and ran on coal fuel. With a 0-2 two-wheel arrangement, these were revolutionary achievements for the 1820s. The rocket won the Rainhill Trials, setting the design prototype for steam railways. It proved that steam railways were safe, efficient, and profitable, starting the era of modern rail transport. Hard coal originated millions of years ago from plant remains in forests and swamps, undergoing transformation through pressure and heat. This process converts peat into brown coal and then hard coal, with content increasing with depth and age. Coal became a key fuel for steam engines and industry. Mining technology evolved significantly in the 18th and 19th centuries, moving from initial manual mining in open cast and underground mines to mechanical hammers and steam pumps for dewatering. The introduction of the first mine railways for coal transport led to greater accessibility and lower cost of raw material. Coal processing involves sorting by quality and calorific value, drying, and preliminary sintering to produce coke. Coke is crucial fuel for metallurgy and heavy industry. Steam locomotives and industrial machines needed high-quality coal with a high calorific value for efficient operation. When comparing the calorific value of coal to crude oil, lignite has approximately 12 to 20 megajoules per kilogram, hard coal 24 to 30 megajoules per kilogram, and crude oil 42 to 46 megajoules per kilogram. Despite its lower value, coal was cheaper and more readily available in the 19th century. In the 19th century, main centers of coal mining included Great Britain, Germany, the USA, France, and Belgium. Specifically, these were areas like the Ruhr Basin, Saxony, and Appalachia. These regions significantly fueled the development of steam railways and factory industry. Coal was an essential fuel for steam locomotives due to its high calorific value, which produced powerful steam. It was also easy to transport and store in stations and wagons, and readily available across Europe and America in the 19th century. Without coal, steam locomotives could not function efficiently. Steam trains enabled the rapid transport of coal from mines to cities and factories. This led to the emergence of the first dedicated railway lines for coal transport. Local mining railways efficiently connected mines with steel mills and ports, increasing the pace of industry and raw material accessibility. Steam locomotives were the catalyst for the economic transformations of the 19th century. They provided a stable energy source for factories and accelerated trade and urbanization. Historical examples include Great Britain, Germany's Ruhr area, and the Harz region, where local locomotives transported coal to smelters and factories. The challenging terrain of the Harz Mountains required special technical solutions. Steep slopes, narrow valleys, sharp curves, and limited space made building tracks and adapting locomotives a significant challenge for the engineers. Technical adaptations for steam locomotives in the Harz included narrow-gauge tracks, reinforced boilers and brakes, and special cogwheels or rack systems for better traction on slopes. These features ensured safety and stability when transporting freight and passengers, allowing efficient operation in mountain conditions. The Harz narrow-gauge railways are a living museum of steam railroading. This network of mountain narrow-gauge railways stretches over 140 kilometers. Steam locomotives have been used here from the 19th century until today, serving both freight transport and tourist traffic. The Harz region's mining and industry history dates back to the Middle Ages, primarily focused on silver, lead, copper, and iron. The development of steam technology and railways in the 19th century significantly boosted the transport of raw materials and coal in the region. The history of the Harz narrow-gauge railways began with the construction of the Selkettlebahn in 1887. This was followed by the Nordhausen-Wernigeroder Eisenbahn in 1898. These lines were built for transporting raw materials and were a major feat of engineering, connecting key mining centers. The most important part of the Harz narrow-gauge railways is the Brockenbahn, connecting Wernigerode with the highest peak in the Harz, Brocken. This line required an ABT rack system to overcome the steep slopes and was completed in 1899, becoming one of the most challenging railway lines in Germany. The steam locomotives used on the Harz narrow-gauge railways are of German construction. They are characterized by a 2102 tank locomotive design, ensuring better traction. They have high steam pressure, reinforced boilers, and cogwheels for mountain operation. Technical parameters of these locomotives include a power of approximately 700 horsepower, a maximum speed of 40 kilometers per hour, a service mass of about 70 tons, and a 1,000 millimeter track gauge. They use hard coal as fuel and are still manually fired by a stoker. The maintenance and operation of the Harz narrow-gauge railways require significant effort. Staff perform daily inspections, refuel with coal and water, and carry out periodic general repairs and boiler inspections, maintaining the tradition of steam railroading. Today, the Harz narrow-gauge railways are a major tourist attraction, transporting approximately 1 million passengers annually. They preserve the tradition of steam traction, promoting the history and engineering achievement of the railway. The railway is an iconic symbol of the Harz region.